All right, let me talk about the and probability. Let's think about this one again. Select a number from 1 to 10. Like we did a little bit earlier. And matter of fact, let's think about what is the probability that we select a number that is odd and a multiple of 3. Now, that might sound familiar because actually we've already talked about this. Yeah, what this is asking is probability that it's odd and multiple of 3. Yeah, this one, yeah, we've talked about this one already before. It's just wanting the probability that it's both odd and multiple of 3 at the same time. Well, from previous discussion, we know the probability that is odd and multiple of 3. We've got 3 and 9 that are odd and multiple of 3 at the same time, right? Both of those would be odd and multiple of 3 at the same time. So there's 2 of them out of, we got 10 altogether, 2/10, which reduces to 1/5. So that and probability we can do this way. However, in a moment, we are going to need to use a formula. So let's think about this in the context of trying to do a formula. Let's rethink. All right, so probability that it's odd and multiple of 3. We said a while ago, and does typically mean multiply. However, let's just try multiplying the 2 components there together. Multiply the probability that it's odd times the probability of multiple of 3, and see if we do get, we know this should be 1/5, but let's see if this gives us 1/5. Probability that it's odd, well, there's 5 out of 10 odd from our 1 through 10. The probability that it's multiple of 3, well, we've got 3, 6, and 9. And so there we have 3 out of 10 are multiples of 3. And if you multiply those together, unfortunately you get 15 out of 100, which if you do reduce, you get, reduced by 5, you get 3 out of 20. Okay. We know that the and probability should be 1/5, but we get 3 out of 20 this way. So, yeah, there's and does mean multiply, but there's a catch, and it turns out there's a catch to it on the second one. What we have to consider, so this doesn't exactly give us what we want. So let me talk about what's known as a conditional probability. And see if we can get this and formula to work out. The conditional probability looks like this. It's B, then a vertical bar, and then A. Yeah, it's the probability of B, what this means. Probability of B given A has occurred based on a condition. Yeah, I'm redoing it, so if y'all want to hear it again. But
You're redoing it?
yeah, I don't really have time to do it? Okay. All right. Okay. So B given A is probability of B given A has occurred. And that's called the conditional probability. So in this first case here, what I want to look at is, well, let's think about this one. Let's think about the probability that it's multiple of 3 given that it's odd. Kind of lines up with our example here. B is the multiple of 3, A is the odd. So what would this be here? Well, the probability that it's multiple of 3 given that it's odd. So we're given this second one has occurred, given that it's odd. So it's an odd number. We've got 5 odd numbers, so we're only taking this one out of 5. So what's the probability that it's multiple of 3 given that it's odd? Well, out of the 5, we've got 1, 3, 5, 7, and 9. And so multiple of 3, which ones of those are multiples of 3? 3 and 9. So 2 out of the 5 are multiples of 3 given that it's odd. So this conditional probability in this case, 2 out of 5. Okay? Well, how does that apply over here? Well, let's come back over here and do a different product. Let's do the probability of odd, but let's multiply it by the conditional probability for the second one, multiple of 3, given that it's odd. Okay? And multiply those two together. The probability that it's odd, still 5 out of 10. Probability that it's multiple of 3, given that it's odd, is 2 out of 5. If we multiply those together, we get 10 out of 50, which is, reduces by 10, is 1/5. Aha. We get a match. So probability of odd and multiple of 3, it equals probability of odd times the probability of multiple of 3, but given that it's odd. So we have to do a conditional probability for the second. All right. So here is the and probability formula. Let me rewrite it again. Probability of A and B equals the probability of A times the probability of B given A. Is how the and probability formula works. You have to do the second one under a condition. The condition is that A has occurred. All right, so let's see how that applies to a couple of problems. First one is 2 cards are going to be drawn. 2 cards are drawn with replacement. Without replacement, sorry. What is the probability, number 1, what is the probability? The first is a king. And the second is queen. All right, well, yeah, here's our little and. Probability that the first is a king, I'll write it this way. And second is queen. So there's our and word, and so that's our formula. Do the probability of the first, king on the first, times the probability that it's queen on the second, but we have to do that conditional that it's king on the first. Okay, well, what is the probability that it's a king on the first? 4 kings in the deck, 52 cards. 4 out of 52 is the probability that it's king on the first. Now, The second part, queen on the second, is probability that it's a queen, but it's given that the king on the first occurred. So in other words, we took the cards, we drew them, drew the first card, and it was a king. So the king, and it's without replacement, so I drew a king and it's not replaced. So there's still 4 queens. However, since one king is gone, there's only 51 cards. So this second probability would be 4 out of 51. So I multiply those together. You multiply the top 2, you get 16. The bottom 2, you get 26, 52. And that does reduce by by 4. I think it's 4 out of 663. Okay. All right. So there's one example where that formula comes in handy. All right. Let me give you number 2 here. 2 cards drawn without replacement again. What is the probability both are spades? Okay, well, in this one, we don't see the word and, but if we write it out, this is going to be the probability that it's spade on the first and spade on the second. That would be how that one would be. If I broke it down into the 2 parts, I got spade on the first and spade on the second. So this is an and probability. So I'm going to do my formula. Take the probability of spade on the first and multiply that by the probability of spade on the second, but given spade on the first occurred. Okay? Probability of the spade on the first, well, there's 13 spades, there's 52 cards, 13 out of 52. But the second one, the probability I have to do there is based upon the condition that it was spade on the first. So in other words, I drew a card and it was a spade. It's without replacement, so it's off to the side here. So how many spades out of how many cards? Well, since I drew a spade, we're down 1 spade, so that's 12. And I'm down 1 card, so that's 51. 12 out of 51 is the second part to that. We lose a spade. Okay? So we multiply that together. 13 times 12, 156. 52 times 51 is 2652. And that one's going to reduce all the way down to 1/17. Reduces by a lot there. Okay?